Assalamualaikum warahmatullahi wabarakatuh to Madam Norayanti. Today, our group will present about our project for our subject, which is CSC510, Discrete Structure. Our project is Smart Door Access System aka SDAS. This project focuses on propositional logic, which is involved true or false statement combined using logical operator like AND, OR, and NOT. We developed a simple online smart door access system that decides whether to unlock a door based on the status of a security alarm and the validity of an access card. By using logical operation, truth table and boolean expression, the system shows how basic logic can drive decision. This concept is highly relevant to real-world systems like digital circuit, security system, and authentication process. This is our project objective, which is the first one is to develop logical argument to validate proposition using propositional logic principles. The second one is to foster teamwork, which is to collaborate on formal logical solution for computing scenarios. And the last one is to apply formal logic, which is to design smart door access system reflecting to real world decision.
Okay, Assalamualaikum warahmatullahi wabarakatuh. And next, I will proceed with our problem analysis, automated door access. In this project, we model a basic automated door access system, which is commonly used in secure environment like office and lab. This system rely on logical reasoning to determine if someone should be granted the access. For our smart door access system, we use two binary conditions. First, whether the access card is valid, and second one, whether the security alarm is off. The door will only unlock if both conditions are satisfied. This kind of decision making is based on propositional logic, which is a key topic in the discrete structure. And next is the logical representation and truth table. Now, let's look at our logical expression for our system. So, we define two Boolean variable, which is A equal to 1 if the access card is valid, and B equal to 1 if the security alarm is off. The logic used is simple. The door will unlock if both A and B are true. In logic, this is written as unlock equal A and B, or A intercept with B. We also prepare a truth table to show all the possible scenarios. As we can see, the door only unlock when both A and B are 1. In every other case, the system denies access and the door remains locked. So this truth table help us verify that our logical expression are work correctly. The next one is a implementation of our web-based SDAS. To demonstrate this logic in action, we build a simple web-based application using HTML, CSS, and JavaScript. First, we use the HTML to create the structure of the user interface, where user can select the status of access card and the alarm. Then, we use JavaScript to implement the logic. It checks the input using a Boolean of AND operation, just like the expression of A intercept with B. If both conditions are true, it will display the door is unlocked. Otherwise, it show locked. And lastly, we also using the CSS to make the interface clean and user-friendly, so user can easily interact with the system. This implementation show that how we can apply the propositional logic in real-world system using the development tool.
So next we talk about SDAS output and effectiveness. For our system output, the system will evaluate the input using logical AND operation. Then it will display unlock when both of access card is valid and security alarm is off. As you can see at the interface, both access card valid and security alarm off is equal to yes. Then the door will be unlocked. Next, we move to the effectiveness. First, we have theory and practice. It will create a clear connection between logical and practical application. The next one, we have web-based simplicity. This system is easy to construct and use standard web technologies. For the last one, we have adaptable logic. The logic is easy to comprehend, facilitating and prototyping. Next, we move to difficulties and limitations. We have 3 points here. The first one is limited condition. The system only supports 2 binary conditions to access the door. For the second problem is input validation. There is no built-in mechanism to account for user error and unusual input. And for the last one, we have hard code logic. The system needs to manually edit for the source code if there is any modification. The last one is conclusion and future improvement. In conclusion, the smart door access system successfully show how discrete structure concepts like propositional logic and truth table and also Boolean algebra can be applied in real-world application. This is the key highlight of the project. First, correct use of logical operations such as AND operation to evaluate 2 binary input, which is access card validity and alarm status. Second, development of fully working web application using HTML, CSS and JavaScript. And the last one, demonstrate how formal logic support real systems such as security and access control. Next, we move to suggestion for future improvement. We can add time-based access, user roles, and biometric verification. The system will include input validation and logic visualization, and integrate a back-end system for data storage and enhanced functionality.
Now, we go to the demo of this project. So, let's start. So, this is the code for the project. So, this is the HTML code, and this is the JavaScript code, which is for the function for the project, how the project works. So this is the design, this is the CSS, the design for the code. So we start by running this code first. We will start debugging. Okay, if it show this. Okay, so this is the smart door access system. So the truth table say that if yes and yes, which means 1 and 1, it will open the door. But if yes and no, or no or yes, we will not open the door. So let's try it. So first, let's try. Okay, so now you see, if the access card is valid and the security alarm is off, so the door will unlock. What happen if we say no to alarm? So we see, so the door is closed. If we say no to access card, so the door remain closed. So that is all for our demo. I hope you enjoy it. Thank you. So